Hello, geometry students. Mr. Zacek back and better than ever. We're in Unit 12, Lesson 4. This one's going to be pretty straightforward. Just looking at volume and surface area of spheres. So a sphere is the set of all points in three-dimensional space that are a given distance from a point called the center. So we think of a sphere as a ball, and then obviously a hemisphere is one half of a sphere. We think about that with our planet. We live in the northern hemisphere. Other people live in the southern hemisphere. It's half of it there. So when we're looking at circles, a great circle is a circle that's the largest circle that can be drawn on a sphere, and the center of a great circle is the center of the sphere. So that's what we get when we get a cross section, or if you rotate a circle around, you create a sphere. So spheres, properties, spheres are perfectly round geometric objects. The intersection is a circle, and then the intersection of a tangent and a sphere is a point. So if you have like a piece of paper that just touches at one point, that only has a point. All cross sections are circles, and a great circle is the largest circle that can be drawn. Its center is the center of the circle. Okay, so two formulas. These are on our formula sheet. So one is the volume of a sphere is 4/3 pi r cubed, and the surface area of a sphere is 4 pi r squared. So obviously the key to using this formula is to correctly identify the radius. So we want to find the radius, and then we can substitute and simplify for those. So find the volume here. So we're given right now the diameter is 12.2. So the radius would be half of that, would be 6.1. So the volume is 4/3 pi r cubed. So the volume would be 4/3 pi times 6.1 cubed. So it says, if possible, leave this in terms of pi. So that's going to be possible for us. So when we enter this in to our calculator, we'll put the 4/3 in first. And because we're going to leave it in terms of pi, we're not going to include the so 6.1 to the third power. So 302.641 pi. So this would be 302.641 pi. Okay. Miles cubed. We can leave the units off, but we're always cubic units when we're dealing with volume. So as you can imagine, that's really straightforward. So one of the ways we add some complexity is to, just throw some other shapes in here. Let's look at number one. The Everswift Tennis Ball Company packages 3 tennis balls in a cylindrical tube with the balls stacked one above the other. The diameter of each tennis ball is 2.7 inches. Assuming there are no gaps at the top, bottom, or sides between the balls and the tube, what percent to the nearest tenth of the tube is not occupied by the tennis balls? So we know that the distance across here is 2.7. And so if we have 3 of these stacked on top, 2.7 times 3 would be 8.1. So that would be our height for this. So it says percentage, but we need to first find the volume of, so if we're going to do the volume of the tube minus the volume of the 3 tennis balls, that will give us the space not occupied. So the tube is a cylinder, so that would be pi r squared times the height. And then we're going to subtract. Now there are 3 tennis balls, so that's going to be 3 times 4/3 pi r cubed. So the diameter was 2.7. So if we divide that in half, that would be 1.35, I believe, is what that comes out to be. So 2.7 divided by 2, 1.35. That would be our radius for this. So we're going to do, so pi, this is the tube, which is a cylinder. So 1.35 times the height, 8.1, minus, now what's going to happen here is the 3's are, that'll cancel out, and this would just be 4 pi times 1.35 cubed. Okay, now I'm going to simplify this, the tube one first, because I'm actually going to need that later on. Whoops, I forgot the squared. Okay, so pi times 1.35 squared times 8.1. So pi times 1.35 squared, oop, too many decimal points, times 8.1. So that would be 46.37. And then we've got 4 pi times 1.35 cubed. So 4 pi times 1.35 cubed is 30.918. So minus 30.918. So we'll subtract those two, and so we've got 46.377 minus 30.918, and so the leftover space is 15.459. So 15.459. So the question though is what percentage is not occupied? So if we take the 15.459 and we divide it by the total volume of the tube, which is 46.37, that's going to give us a decimal that we can convert to a percentage. So we take that number divided by 46.377. Whoops, I didn't, forgot the decimal point. Let's try that again. 15.459 divided by 46.377 is 0.3 repeating. Okay, so 0.33 repeating. So if we convert that to a percent to the nearest tenth, that would be 33.3% of the tube is not occupied. Okay, so you know the sphere part of it is pretty straightforward, but we have to kind of mix it together with a couple different things. Here we go. A snow cone is completely filled with ice and has a hemisphere of ice on top as modeled in the two-dimensional representation of the three-dimensional objects. Find the total volume of ice to the nearest tenth of a cubic centimeter. Okay, so when you have, first thing we need to see is that since this is a hemisphere, all the radii in this are going to be the same. So this will be 7 as well. But in order to figure this question out, we're going to need to find what this length is right here. I'm going to call it x. Well, that's a right triangle, and I know so if we just take that right triangle and draw it out over here, we've got 68, we've got 90, 7, and x. Okay, so this would be our opposite side. This would be our adjacent side. So the tangent of 68 would be x over 7. So the tangent of 68 times 7 is what we have going on here. So the tangent of 68 times 7 is 17.3256. Okay, so 17.3256 3256, that's going to be this value right here. So 3256. So basically what we have here is the volume of a cone. So the volume of a cone plus the volume of the hemisphere. So the cone is going to be pi r squared h, and the hemisphere is going to be half of 4/3 pi r cubed, because a hemisphere is only half of the circle. So we have pi, our radius is 7 squared, and for the height, that's where the 17.3256 comes in, plus 1/2 times 4/3 pi times 7 cubed. And then we're just going to put all of that in, and that will be our total volume. So let's see if I can, so pi times 7 squared times, I'm just going to do control answer, that's the previous answer, plus 1/2, arrow to the right, times 4/3 times pi, and then 7 to the 3rd power. So 3,385.45. 3,385.45. 3,385 point, nearest tenth of a centimeter, 0.5 cubic centimeter. So that's how much the volume of ice that you get in the ice cube. Okay, a couple more here. So challenge questions making us put these multiple ideas together. An aquarium in the shape of a rectangular prism with a length of 20 inches and a width of 12 inches and a height of 12 inches is filled with water. You drop a spherical ball in with a diameter of 6 inches into the aquarium. The ball sinks, causing water to spill from the tank. How much water to the nearest gallon is left in the tank? Oh my. All right, so we got a little hint there. So it's probably a volume question. All right, so first of all, we've got a rectangular prism here. And the formula for a prism is going to be length times width times height, or the area of the base times the height. So our volume is going to be 20 times 12 times 12. Okay, so let's go ahead and calculate that first. So 20 times 12 times 12 is 2,880. So 2,880. So now the ball, we drop a ball in, okay, and the ball has a diameter of 6 inches. Meaning it has a radius of 3 inches, and the volume is 4/3 pi times 3 cubed. So basically, whatever the volume of the ball is going to spill out of that. So if we put this in, so we've got 4/3. Called displacement, right? The ball is going to displace in here, times 3 to the 3rd power, so 113.097. So the volume of the ball is going to be 113.097. So I should, when you're doing multiple volumes, we should write down what these things are. So the volume of the aquarium. All right, so that amount, the ball sinks, causing water to spill. How much water to the nearest gallon is left in the tank? So what we need to do is we need to subtract 2,880 minus this 113.097. Okay, so that's going to be our next piece is 2,880 minus our previous answer is 2,766.9. So 2,766.9. That's the remaining. So remaining volume. Now, if we take that and we divide it by 0.00433, or excuse me, if we multiply it by that, then we will get the number of gallons that we have. So we take that number and we multiply it by times 0.00433. So we get 11.98 gallons to the nearest gallon. So 12 gallons remain. All right, again, so we're having to think through some just kind of different ways that this is going to be presented to us. All right, there's a couple more here. I think they're good ones, but we've done some, I think you've got the idea and you've got the pieces that you have here to finish this up. So again, these two formulas will be on there. Your assignment has some of these types of questions, so we're going to have some more chance to practice and have some conversation about it. So good luck with that. We'll see you back here soon in lesson 5.